Welcome to qnawire.
In this problem, we're going to find a mathematical relationship between the point of water and the external pressure. We're going to start by making a plot of the pressure in pascals versus 1 over the temperature in Kelvin. We're going to show that the plot is a straight line. We're going to find the slope and the y-intercept of that line. After that, we're going to write that equation in the form P equals B times exponent of minus A over T. And we're going to find the values of A and B. So we can start by analyzing our table over here. And the first thing that we notice is that the units are in Celsius when they should be in Kelvin. So let's just switch it up to Kelvin by adding 273 to each one of these data points. So after adding 273, we're going to get these values. You can calculate it by yourself. And we can already start doing 1 over T for the temperature and taking the natural log for the pressure. And if you plug it in your calculator, you're going to get these values. With these values, we can start plotting our graph. And let me pick up my graph over here. And let's start with the first data point, which is going to be 0.003, 9.41. Should be around the end over here, near the middle. So somewhere around here. So for the second point, it's going to be 0.03 around the line, almost at 10. So somewhere around here, a little bit to the side. We can keep doing this for all other values. And let's just pick up the last one for the sake of time. And it's a little bit over 13 and 0.0236. So around here. We can do another point just around the middle. We can find the 0.02. Let's use this point over here, 0.00275. 275, it should be around here. And 11.15, so a little bit above the 11, somewhere around here. So the graph looks like a straight line. Let's draw the straight line. And let's calculate the slope in different points to make sure that it is a straight line indeed. The formula for the slope, as you may know, is the change in y, y2 minus y1, divided by the change in x, x2 minus x1. Let's use these first two data points. So let's start by subtracting these two, and we're going to get 0.48112, and then divided by the difference in the x. So this value minus this value over here, and it's going to be negative 9.297 times 10 to the minus 5. If we divide these two, you're going to find that slope here is going to be approximately minus 5,000. We can do this again for another data point. Let's say this last data point and this one over here before the third to last. So if we calculate that, it's going to be 1.55 divided by 3.169 times 10 to the minus 4. And again, we're going to get minus 5,000. If you want to pause the video and calculate it by yourself, go ahead. The slope shouldn't change too much between these values, and you can pick any two sets of numbers to do this. So let's move on to finding the y-intercept. For the y-intercept, we can use the equation of a line, which is y equals x plus b. This is a b, sorry. Whoa, let me do that again. X plus b. We already found a, so y equals minus n plus b. And we can substitute 5,000x. Oh, sorry about that. 5,000x plus b. And then we can substitute any data points in here. And let's just use a random one. I'm gonna use 10.34 over here for the y. 0.348 equals minus 5,000 times 0.0029154 plus b. If you solve this equation, you're going to see that the slope b is going to be equal approximately to 25. Again, you can use any of these data points to, if you want to do a double check, make sure that you got the right number. But this is the slope over here. So found the slope. Oh, I'm sorry. We found the y-intercept, and we also found the slope. So what we're going to do next, so we did this, and we found the intercept. So next we're going to prove that we can write the, oh yeah, let's write the final equation just to be consistent. So log n of p is going to be equal to minus 5,000. X was 1 over t plus 25. So I want to show that equation in this format, and we can do it by two different ways. We can either use this equation and manipulate it to get it to this format, or we can manipulate this format and try to get something that looks like our equation. And for this case, I think this one's the simpler one. So let's just start with p equals b times e to the minus a over t. And since we want to move it to a natural log, we're going to have to make sure this b becomes exponential somehow. So what I'm going to do here is a variable substitution. In a variable substitution, I'm just going to assign another variable just so it's easier for me to work with. And so I'm trying to move this b to something else, and it has to be an exponential. So b is going to be equal to an exponential to, let's say, k. So this equation now becomes b equals e to the k times e to the minus a over t. If we use the power rule over here, we find that p equals e to the k minus a over t. Okay, now that we have an exponential over here, we can put the logarithm, the natural log, on both sides. On the right-hand side, just simply natural log of p. And then on the right-hand side, the natural log is going to cancel out with the exponential, and we're going to be left with k minus a over t. So at this point, the equation already looks a lot like this one, but we can already manipulate a little bit more and make it even more alike. So let's do this right now. Log n of p is perfect on this side. And then we want to have 1 over t and something multiplying it. So minus a times 1 over t. And then we just have to sum with what is left over here, which is k. And we can already see that we have the same equation on the same format, and we showed that it can be written on that format. So what we do next is we're going to calculate a and b, but here we have a k. So just by looking, let's start with the easier one, which is a. And just by looking at it, we can already tell that a is going to be equal to 5,000. And here we have k, and we know that k is equal to 25 just by quick inspection. So k is equal to 25. Now we're going to go back to that variable substitution that we did earlier, and we're going to plug in this k that we found over here, and we're going to find what b is. So b is going to be equal to e to the 25, which in turn is going to mean that b is going to be equal to 7 times 10 to the 10. Looking at the units on this first format over here, we know that here we need to have pascals as the units. And here we have Kelvin. Since there's no Kelvin on this side, we have to make sure to cancel out this Kelvin, which means that we have to assign a Kelvin units. And then since we have already canceled this out, the right-hand side has to have the same units as the left-hand side. So that means that b is going to have Pascal units. Now, if we can plug it into our answer over here, we have that a is going to be equal to 5,000 Kelvin, and b is going to be equal to 7 times 10 to the 10 pascals. And that is it for this problem. We just finished. We just finished all of it, and we're done.